Hi all. In this video, I am going to explain about switched mode power supply, which is commonly called as SMPS. Generally, we have three different types of SMPS: boost, buck, and buck boost converter. There are few other types also, flyback converters. We are going to see only these types. Generally, we call this as step up converter, step down converter, and step up, step down converter. So this is called as step up, step down, and step up, step down converter. First, we are going to see the derivation of step up or boost converter. This is the circuit of boost converter. What do you mean by a boost converter? If I have a 20 volt here, assuming this is my power supply and this is my load, I'll have a load more than 20 volt, which means V0 will be greater than Vs. So that is called a step up converter or boost converter. How does we obtain it? We'll just observe or understand the operation of the circuit. We have a supply, inductor, diode and capacitor and a load, a resistor and a switch. The reason for making this diode to be by this way is the current flows from source to load, not from load to source. Now when the switch is present here, when the switch is on, we'll see what happens, and when the switch is off, which means open, let us see what happens. First case, when the switch is closed, see here, once the switch is closed, these elements are disconnected. Why? Because this is short circuited. Current flows in the path of the switch rather than flowing through this way. So the elements present in the circuit are right now, it is reduced to supply, inductor and switch alone. Remaining are disconnected or it is not connected in the circuit at all. So what happens during this condition? Inductor is getting charged, and it is we'll observe the waveform and we'll understand much better. As I said, during this condition, during this position, the inductor is getting charged. We'll see how it is getting charged. It is charging from a minimum value to a maximum value. The current in the inductor is getting increased from a minimum value to a maximum value. This is the T on condition, switch on condition. Now when the switch is off, which means open, what happens is this entire line is absent in the circuit, or will not it is eliminated. So we'll have supply, inductor, diode, capacitor and also the load, nothing but the resistance present in the circuit. That is what drawn here. Now supply, whatever Vs will be available across the load. It is not just Vs that is available across the load. Along with Vs, the energy stored in the inductor will also be available across the load. That is why it is Vs plus Vl, which is equivalent to V0. And hence, V0 will always be greater than Vs. The energy in the inductor will also be delivered across the load, and hence it is more, output voltage will be more compared to the source voltage. So during the switch on condition, T on, inductor current is charged, and see this line is decreasing. Why? Because inductor is discharged or the energy in the inductor is released during the off position or when the switch is open. So this is charging and this is discharging for T on and T off. And the IL is actually fluctuating between IL minimum to IL maximum, not from the zero. These are the few parameters that we are going to analyze. First is we'll understand what is the load current and load voltage when the switch is on. So when the switch is on, it is Vs minus Vl, inductor current and inductor voltage. So Vs plus Vl equal to 0, source plus load equal to 0 because this is the load as of now. So Vl on is nothing but voltage across the inductor when the switch is on. So it is equal to Vs. Likewise, when we check for the apply KCL, we'll get this IC plus I0 equal to 0 because diode is not conducting, and hence we'll get this value. This is how we get it. Okay, because the diode is not conducting, we'll have only this, and so the current flowing through this is just this, the inductor current. capacitor current is equal to the output current minus of the output current. Now when the switch is off, which means the entire circuit is present, what happens to the VL and IL? Same Kirchhoff's voltage law is applied. Vs minus Vs plus VL off. The VL off represents voltage across the inductor when the switch is in off condition or in open condition. Plus V0 is the output voltage. So at last we'll get VL off equal to Vs minus V0. Similarly, when we apply KCL, we'll get the IC off capacitor current IC off equal to IL minus I0. Inductor, now in this case, inductor current is equal to the diode current. Next is volt second balance. So we try to derive it Vs into dt plus Vs minus V0 into 1 minus dt. Why? Because this is the duration, you know this. And so finally we'll get the duty cycle, which is like V0 equal to Vs by 1 minus d. So the duty cycle is practically between 0.96 or 97. V0 is always greater than Vs. So voltage is boosted. Similarly, when we try for this current, we'll apply IC on into T on plus IC off into T off equal to 0. So at last we'll get the derivation as IL equal to I0 by 1 minus T. The point is IL depends on the duty cycle. Same way V0 depends on the duty cycle. Next is the ripple inductor current change in IL. So VL on we have already found equal to Vs. Then L into del IL by dt, replacing that equal to Vs. At last we are finding the equation for del IL, change in the inductor current, that is equal to Vs into d by FL. Hope you understand with this graph. This is IL minimum and IL maximum, and the average value is the mid value between the IL max and IL minimum, and that is del IL by 2. That is what is written here. The next one. Next is IL max. IL max equal to IL plus del IL by 2. So substituting those values, IL equal to I0 by 1 minus D and del IL by 2 is the same, which is nothing but this IL average is nothing but the IL. So we get the IL max equation. Seventh one is IL minimum. It is IL minus del IL by 2. And so substituting those, we'll get the answers. Next is the source current. We know P in power input is equal to the power output. So Vs Is equal to V0 I0, and hence Is equal to V0 I0 by Vs. Switch current is ISW average. Is average equal to into dt by t. When the switch is on, this is the condition, and so it is d into IL average. So Is average is equal to d into I0 by 1 minus d. When the switch is off, we'll be finding the diode current, because when the switch is on, the diode current will not be available. So ID average equal to IL into 1 minus d by t into t. It gets cancelled, and ID average equal to I0. So this is how we find ID RMS also. And ISW switch RMS is found by this way. This is the final derivation for the ISW RMS. This is the IL average waveform, and this is the switch waveform, because switch is on only during the T on period, and so it is only this waveform. IL average is common, like it is the straight line, which is between the mid value between the IL max and the IL minimum. Same way, diode current is available only during T off, so the pulse is available only during the T off condition. And next is the ripple and capacitor voltage. Del Vc equal to del V0. During on period, the inductor changes because it discharges. The energy in the inductor is getting discharged. It is getting charged. So IC equal to minus I0, and this is how you get it. So voltage across the capacitor will be between V max and V minimum, and the ripple will be found as V minimum minus V max equal to this. It's observed that when the D changes, capacitor voltage also changes, which means when it is increasing, the capacitor voltage increases. Critical inductance. inductor current is continuous, it's actually not discontinuous because it varies from IL minimum to IL max, then IL max to IL minimum, again starts from IL minimum to IL max. So it is continuous, it's not discontinuous. So IL minimum equal to, if we are assuming it is 0, IL, you will get it as LC equal to this equation. Same way CC, critical value of the capacitance, is found here. VC minimum is equal to 0, then we'll get the CC. Thank you.